Hello everyone, welcome back to my channel. I'm the guy wanted to explore chemistry with all of you, and you're watching ChemBugs. So today before I start my video, I would like to ask you a question. But before I ask my question, let me tell you something about my previous video, that is Electrophile generation part 1. Okay, in that video I have used Hindi language, right? So on that, one of my friends suggested me to use English instead of Hindi language. So my question to all of you is that which language should I use to make videos, English or Hindi? So guys, you all have got the tutorial for Hindi language in my last video, and you can get the tutorial for English language in this video. So watch the video and let me know your opinions below in the comment section. And one last thing before I start my video is that I request all of you to watch the video till end, because you will definitely get to know something new here. So guys, let's start the video with a peaceful intro. Let's go. So guys, first of all we are going to see F-C Acylation. Okay, now we all know that what happens in F-C Acylation, that a benzene ring is reacted with any alkyl chloride in the presence of Lewis acid, that can be any Lewis acid, AlCl3 or FeCl3, to give a product. Here we are getting anisole as a product and HCl as a byproduct. Okay, we all know that. So let's move on the next slide. So guys, in this slide I'm going to show you that how electrophile is get generated in the acylation, or you can also call it as activation of electron with Lewis acid. Okay, so let's see what is going on here. So first of all, let's see, you can see this acetyl chloride molecule over here, and also this electron pair arranged around this chlorine, right? So what will happen over here, this chlorine will forcefully donate its electron to this AlCl3, due to which a negative charge will acquire on this AlCl3 and a positive charge will acquire on this Cl chlorine atom, right? It's obvious, and a bond will form between them. So as we all know that chlorine is a electronegative species, and it requires electrons to stabilize itself, and as the positive charge has been acquired on it, it has got destabilized, and to stabilize itself, what will it do? It will snatch this electron pair shared between the chlorine and the carbon and get away as AlCl4 and get stabilized, but that will result into the destabilization of this carbon atom. This carbon atom will get converted into this carbocation, but as we know that this carbon has its unique what we call that attribute or quality, that it has the power to stabilize itself. So what will he do? What will this carbon will do? This carbon will borrow one of this electron pair on this oxygen atom and form this type of triple bond and forms this type of complex. Okay, now this complex is also known as acylium ion, and this is the temporary stabilization of carbon until the benzene doesn't arrive. Okay, so let's see, let's move on the next slide. Here when the benzene arrives, this acylium ion, what will do? This acylium ion will oxygen atom will take back its electron, and the positive charge will again acquire. Let me show you something. Let me show you by drawing it. Here it is. Okay, now this as it has taken the this one of its electron pair, this oxygen atom is now stable because it has the two of its electron pair, and this carbocation will again form, and this carbocation will get attracted with the pi bonds of the chlorine of the benzene, sorry, and forms intermediate sigma complex. Here the sigma complex has not shown, but you all know that what is sigma complex. that it is a resonating structure of three resonating structures, and by deprotonation of that sigma complex. Guys, let's look at the nitration. It has, so guys, be aware because it has a different mechanism. Fidelcraft acylation was easy because it has the similar mechanism as acylation and halogenation. So be aware. Now first of all we will see its general formula, and then we will move on to its electrophile generation mechanism. Okay, so we all know that what happens in nitration, that benzene is reacted with nitric acid, and in the presence of concentrated H2SO4 to give nitrobenzene, and we also get a H2O as a byproduct. Okay, so let's move on to the next slide, and here's the electrophile generation mechanism. So guys, let's see the electrophile generation mechanism in a nitration of benzene. So first of all, you can all see this nitric acid over here, right? Now many of you will question that why this positive and negative charge get acquired on this nitric acid. So let me tell you that nitric acid is exists in two resonating structures. So guys, if you don't know about two resonating structures of nitric acid, don't be worried, I will add a picture or somewhere around here so that you can, for your reference. For now, let's come back to the point. You can see this the sulfuric acid over here, right? So this sulfuric acid will try to react with this nitric acid. So for reacting with the nitric acid, the sulfuric acid is need to ionize itself. So how will it get it will ionize itself? So you can see this oxygen over here, right? This oxygen, as electronegative species, this oxygen will snatch bond pair shared between the oxygen and hydrogen, and get negative charge on itself and get separated as HSO4 minus. Okay, and this proton gets separated as H plus. Okay, now what will happen to this proton, that this oxygen, negative charged oxygen over here, will share one of its electron pair with this oxygen and get stable as it has a negative charge on itself. Okay, and form this type of complex over here. Okay, this complex is known as nitrite hydrate. Okay, now what will happen? So guys, what will happen next, and another molecule of H2SO4 will arrive and try to react with this nitric acid. Okay, now what, as a result of which H plus ion will liberated. Okay, now this oxygen of nitric acid will share one of its electron pair with this hydrogen atom and forms a structure complex like this over here. Okay, now as we all know that oxygen is an electronegative species, and it also requires electrons to stabilize itself. So after giving the electron pair to hydrogen atom, it acquired positive charge on it, so it has got destabilized. So to get stabilized, what will it do? It will snatch this electron pair shared between the nitrogen and oxygen and get separated as H2O over here like this. Another reason for why this H2O is getting away from this complex is that H2O is a very good living group, and therefore it is taking this electron pair with it and get separated okay, from this group. Okay, now after the removal of this H2O, this whole complexes get converted into another complex like this. Okay, so what had happened here? So let me show you on the next slide what had happened here. As you all know, this complex was there, right? After the removal of this oxygen will snatch this electron pair and get separated as H2, as we all know, right? And due to that, what will happen? A double negative positive charge will acquire on this nitrogen, due to which it will get highly unstable, and to stabilize it, what will this oxygen will do? This oxygen will provide one of its electron pair to this nitrogen and forms a double bond like this, and acquires a positive charge on it. Okay, as we all know that oxygen is a electronegative element and requires electron to stabilize it. What will it do? It will again snatch electron from this hydrogen, and this hydrogen will get separated as H plus ion, and a nitronium ion, we will get our nitronium ion. So guys, this was the simple electrophile generation mechanism for nitration, that how nitronium ion is generated. Now this generated nitronium ion will go to benzene and attack on its pi bond, and forms the resonating structures, that is sigma complex, and then after that deprotonation of that sigma complex, we will get our nitro. So guys, let's look onto the sulphonation reaction. We all know that what happens in sulphonation, that benzene ring is reacted with sulfuric acid, sulfur trioxide in the presence of concentrated sulfuric acid to give benzene sulfonic acid, right? Now I know that many of you will question that why this sulfur trioxide is mentioned over here. I mean, in books we have generally seen 2H2SO4, and we have never noticed this sulfur trioxide. Okay, right? So let me tell you that when sulphonation is carried out, the SO3 gas is passed through the mixture solution of a reaction, and that's why this sulfur trioxide is mentioned over here. And in fact, this sulfur trioxide plays a very important role in the formation of electrophile, that I will show you in the next slide. And this mixture of sulfur trioxide and H2SO4 is known as oleum. I know that you have heard that word somewhere before, so let's move ahead. So guys, here we are. Let's look at its electrophile generation mechanism. So what is happening over here? Let's see. First of all, you can all see this sulfur trioxide molecule over here, right? And this electron pair arranged around these oxygen atoms. Okay, now, and also this sulfuric acid over here. Now this sulfuric acid will try to react with this sulfur trioxide. So, but to get involved in this reaction, this sulfuric acid has to be ionize itself. Now we all know that how will it ionize itself. This oxygen will snatch this electron pair shared between the hydrogen and oxygen and liberates H plus ion, and this sulfuric acid will get separated as HSO4 minus. Okay, now this H plus ion, now one of its this oxygen of sulfur trioxide will donate one of its free electron pair to this proton, and which results into the complex like this. This is known as sulfonic acid, right? This is how the electrophile get generated in the sulphonation reaction. That was easy, right? Then this sulfonic acid will go to benzene and react with its pi bond and forms this type of complex, that is sigma complex, and will by deprotonation it will give benzene sulfonic acid. So guys, that was the simple mechanism for electrophile generation in sulphonation. And now, as we have all known about its electrophile generation, let's see why sulphonation is reversible out of all EAS mechanism. Yes guys, finally we are going to see the reversibility of sulphonation. So let's find out its mystery. So guys, let's look onto the reversibility of sulphonation. But before I tell you about its reversibility, I want you to keep 4 very easy points in your mind. First one is that the mechanism for a reversibility of sulphonation is completely opposite of the mechanism for sulphonation. Okay, now the second point is that the H plus ion here is acting as electrophile, not SO3H plus. Okay, and the third point is that it is only possible in the absence of SO3. Okay, the reversibility of sulphonation is only possible in the absence of SO3. Okay, and the fourth point is that the benzene ring chooses to gain stability instead of strong electrophile. Okay, now let's move ahead. Keep this 4 point in your mind, okay guys, while I am explaining you the its mechanism. So guys, reversibility of sulphonation has 2 steps. Okay, so first step is a protonation of a ring. Okay, that is addition of H plus ion in the ring. So you can see this benzene sulfonic acid over here, and this H2SO4 over here. Now this H2SO4 will get ionized and liberate H plus ion. Now this H plus ion which is acting as electrophile will attack on this carbon which is attached to the this sulfonic acid group. Okay, now so guys, but one side note, I want to give one side note that this H plus can attack on any of this carbon on the benzene. Okay, it is not necessary that it is acting on this specific carbon only. It can attack on any of this carbon. Okay, but generally it attacks on this carbon, and due to that reversibility of sulfonation is possible. Okay, so what will happen after attacking? It will form a complex like this, carbocation intermediate, right? So let's move ahead. Now let's look at the step 2 of this reaction of this mechanism, that is loss of SO3H. So you know guys, I have told you about the fourth point in the last to last slide, that ring chooses to lose this strong electrophile instead of this H plus ion. Now many of you will question that how can that even possible, because SO3H that is a strong electrophile and H plus is weak electrophile. So how can it will get lost out of this benzene? So guys, you know that carbon has a special ability to stabilize its carbocation, and to stabilize that carbocation, it will do anything. Anything, it can do anything. So what will it do? It will lose this sulfonic acid over from here and form this benzene, which is more stable than the benzene sulfonic acid. That's why benzene chooses to lose this strong electrophile over here and form benzene to gain aromaticity, that is stability. So benzene is craving for benzene is craving for stability, and therefore it is forming this it is doing like this. Okay, so guys, after formation of this benzene, you can see this sulfonic acid gets separated over here, right? Now this oxygen gets destabilized. So what will it do? It will snatch this electron pair, and this H plus ion produced over here will go to this HSO4 minus and form H2SO4, and this formed sulfur trioxide will escape from the system, due to which the reformation of benzene sulfonic acid will be impossible, and that's how it will irreversible, and the product will be and the reaction will be in its initial form. So guys, do you know the another reason why this benzene chooses to leave this strong electrophile instead of this H plus ion? Want to know? Then stay tuned, I will tell you in my next coming video. So guys, कैसी लगी आपको मेरी इंग्लिश? अच्छी लगी तो भी कमेंट कीजिए, और नहीं लगी तो भी कमेंट कीजिए, और ये भी कमेंट कीजिए कि आपको वीडियोस इंग्लिश लैंग्वेज में चाहिए या हिंदी लैंग्वेज में चाहिए। तो मिलता हूँ आपको अपनी नेक्स्ट वीडियो में, तब तक के लिए गुड बाय।